Number 35. This is a very good question. What are the zeros of the function? So what that means, start there because that's important to understand. It is asking us which values of x will make f of x equal 0. So for example, if you put that in a table of values, which is probably what I would do, but I like tables, so if you don't want to do this, you certainly don't have to. But we're looking for the values of x such that f of x, and remember that's the same as y, it's just in function notation, we want to zero out the function. Now, one thing you could do if you just didn't know what else to do is start substituting the values in there. So, for example, you could take the function and plug in each of those answer choices, but you would have to do that 5, 6, 7, 8, 9, 10, 11 times to see what you came up with. So that's not the ideal way, but it would work. For example, let me take the first choice, which is a 0. So let's plug in the first option. A is 0. So f of 0 equals 0 to the third power plus 5 times 0 squared plus 6 times 0. And sure enough, this zeroes out. So we know that when x is 0, y is 0. That point checks out. But then you would have to check all the points that way. And you can do that if you want to. That's one way to solve this. But they're wanting you to solve it algebraically. And here's what that would look like. F of x equals x to the third plus 5x to the second plus 6x. So the first thing I'm going to do is factor out an x. So I'm going to pull one x out, and then I would be left with x squared plus 5x plus 6. So you take an x out, and then you're left with a trinomial that you can factor again. So I'm going to take this trinomial and turn it into the product of two binomials. Now don't forget about this little guy sitting out there in the front. We're going to use that in just a minute. But to do this one, we need to find ways to multiply to get 6. So we could say 1 times 6. We could say 2 times 3. And I like that 2 times 3 because if I add 2 and 3, I end up with 5, positive 5. And that's what we want to do. So then we get an x in the beginning of each of those binomial terms. And I'm not changing anything. I'm just going to change the color. I forgot to go back to blue. So you have x plus 2 and x plus 3 as those terms right there. Now we need to do the zeros. This first term, just the plain x, is not going to be a problem because we know that x by itself gets set equal to 0. We've already proven that, by the way. X is 0. Then we need to take x plus 2 equals 0, and we need to move that negative 2 over to that side, so x is negative 2. So that would also give me a y of 0. That is this one. And then we need to do it again so that we get x plus 3 is 0. And in order for that to be true, the x would have to be negative 3. That makes a 0 output. So once you do that 3 times, you have your x values that will give a 0 in the output. So I would go with answer E, 0, -2, and -3. And you had asked me a question specifically about that one, so let me make sure that I have answered that. Why is 0 included with the -2 and 3? That is because of this situation. The 0 that you the x that you factored out can't just go away. So you set it equal to 0 just like the others. So x is 0, y is 0. But it's also true that when x is -2 or -3, y will equal 0. It's a good one. I haven't seen one of those in a very long time.